Hello students, I hope you're doing well. Today I wanted to talk to you about series troubleshooting. So what I'll be talking about today is what happens when we're dealing with a single component, a single fault in a series circuit. So let's assume right now that we have a circuit, and we'll talk about shorts and opens here, the two discrete possibilities that we'll consider. This first one is shorts. And in a short, if I were to take just a single resistor and I were to take a jumper wire here and put that across my resistor and I measure the ohmic value of that, then that resistor would read 0 ohms. So the resistance of a short is 0 ohms. So there is no resistance across a short. When I mean no resistance, I mean 0 ohms. And then likewise, if I were to put a source on this, in this case I'm just drawing a 9-volt battery, 3 series in a simple series circuit, and I were to take that same wire and short it across my R2, we know that electrons will follow the path of least resistance. And the voltage that I would read across a short would also be 0 volts. If there's no resistance there, there's going to be no volts for it to drop across. Okay, so no voltage will drop across that. So let's take the converse of that. Let's take the opposite of that, which would be opens. And if I take a resistor and it's open, when I read that ohmic value, that resistor is going to read infinity. So resistance is an open, or of open is infinity. And if I take that same circuit, a 9-volt battery, and I were to simulate an open or take a resistor with very high resistance, then all the voltage is going to be across that open. Okay, so my 9 volts that's applied here, the voltage of the source, the voltage of the applied source there is going to be 9 volts. And no voltage to be anywhere else. Now I'm looking at simple voltage drops. I'm not looking at any reference ground readings, but just simple voltage drops. So that's how we interpret opens and shorts. What happens to them with the resistance of each of those components and what happens to a voltage drop there. So I've taken just as an example here, I've taken 4 resistors in series. We applied 8 volts. We took these 4 resistors. I picked these values and you get a total resistance of 800 ohms. And if I build this circuit, these are the normal values. 8 volts divided by a total of 800 ohms would be 10 milliamps. And I go through the process of calculating what each one of those voltage drops would be. So now what I've done with this and these faults, and I'll have these handouts for you when you come to class, when you come to lab to look at these, is these are the different faults: R1, R2, R3, R4 open, and then R1, R2, R3, R4 open, and I've listed what the values of those would be. So that should help you out there. And then what we're intending to do today is we're going to build a circuit where we're actually going to do something similar to this, and we call this the black box. I think this is Supplemental Lab 4.1, and we have troubleshooting here. We have 4 resistors. The actual resistances in the 4.1 lab will be different than these. These are just for example sake, so you can study for them. And I've picked some pretty easy values. I've applied 12 volts to well, it looks like I have 12 volts written here, but I think my actual values are, well, these values are a little bit different here. Yeah, I think my sample here is, I think the voltage are right, but my IT should be 2 milliamps. Is that right? Well, I got 12 volts, and I've got 1, 2, 3, 4, 6. Yeah, I got 12 volts and 12,000 ohms, so that gives me 1 milliamp. So I would look at these faults here. If I have a black box A, if I have R1, R2, or 0, R3 is 12 volts, and R4, these are voltage readings, not resistance readings. These voltage readings are no amps. Then I've got to open on R3 on this very first one. The second one here is you see that I have a voltage drop on R1. It's above average. Have no voltage drop on the resistor of R2. The voltage drop on 3 or 4 are above average, so what that would indicate is my current is above average, means there's a short. The short is wherever there's no voltage drop because there's no resistance. So in this case on box B is resistor 2 is shorted. So these are designed for you just to look at and to sort of figure out what's going on with these particular resistors and how to evaluate them. So just want to do a quick video so you guys can look at that, and we'll get some more hands-on in lab. Thanks a lot, and we'll see you in lab.